Welcome to my demonstration. This demonstration will show the journey I took from developing a very simple piece of code. It's a piece of Python Flask. I then took that code and developed it into microservices. This enabled me to really learn Podman. And then I took that code effectively and moved it into Openshift, where I created some templates and some Helm charts. The idea of this particular demonstration is to really aid our sales guys in pre-sales to have a better understanding of the process and then be able to talk knowledgeably to our customers about this particular process. The use case here, as we can see, I've developed a small application. It's called the hit list. I'll show that shortly. It doesn't really matter what the application is. It's, in this case, a microservice application with a SQL database backend and a Python Flask front end. The demonstration will move from simple source code right up to a source to image process using Openshift templates and Helm charts. And hopefully this will generate pre-sales interest and enable us to talk to our customers and show how easy it is to take a developer approach to developing code and then pushing it into larger infrastructure systems such as Kubernetes or Openshift. And hopefully it's a valuable teaching aid for my colleagues as well. The hit list application was developed by myself. It's a tongue-in-cheek application, really, detailing my pet hates and my punishments I'd inflict if I was in charge. So, for instance, I hate cucumbers, so they would definitely be on my hit list. It utilizes a SQL backend that contains the information, and that will be primed from a file that will be held up in my GitHub repository. So this is a source to image process. As I said, the front end is a Python Flask application. The initial development was done locally without any container technology, and then I moved into Podman using small container instances, and then into Helm charts and Openshift. So let's look at the initial stage. This is the initial coding, and if I flick over to a screen here, I can clone that from my repository. So this is a GitHub repository. I'm going to go into this directory, and I've got my various code for the different stages that I actually went into. First stage was the static test. So in here, the imported data actually is held in memory as a dictionary. So it's contained in this file here. In my later code with source to image, it's actually held in a directory and read in as a source to image mechanism. So in order to launch this, I'm just going to say Python 3 and pick the offenders file here, and this will launch for me a Python Flask application. Note it's on socket 5000. So if I go over here, I'm going to just launch Firefox locally, and I've got that tunneled back to my display here, so we should be able to see what goes on with this application, and hopefully, Firefox will fire up, and we should see our simple application running. And there it is. So we can see the various things here that I've put that I dislike, and celebrity chefs being one of those. And if I click onto that, it will just pull up a Python call effectively to some static images. Those images are held inside the Python Flask application, but as I develop this application, hopefully they'll be contained within MongoDB. And we can see that each screen here now has an entry you can click on that takes you to a relevant Wikipedia page about the thing that I dislike. So that was my initial stab at developing the code. All worked fine, no problems with that. But obviously I now needed to move that on because there are several issues here. It's not scalable. As you saw, it's not easy to start and stop the actual code there. it needs to install tooling and languages onto the local machine. So I had to install Python, I had to install Flask and some of the other libraries and so on. And the solution runs on local socket 5000. So routing that from the internet from users is going to be difficult to customize. So this really lends itself to simple customization using containerization, i.e. microservices. So moving on from my simple application, I then wanted to containerize these services to build microservice applications. To do this, I installed Podman locally. So Podman is a tool identical really to the Docker tool that you might be familiar with. And within this, I effectively wanted to run a SQL container. I needed to populate that SQL container with the import code, which I've now moved into a separate file effectively. And then I would need to create another image, a microcontainer image that contained the Flask application. And to do this, I utilized a Docker file and used the podman build process to do that. So we're taking our application and we're moving from a simple monolithic application and incorporate it into microservices or containerized services. So this is something typically that developers would do. So Podman is used to run both the MySQL and the Flask container images. And this was actually fairly straightforward. If we look at the SQL MySQL instance first, rather, we notice here that I'm going to do a podman run, detach it in the background, and expose port 3306, which is what SQL runs on. And then I'm going to pass it some parameters for the initialization of the database, a username, a password. Here I've got the actual database name, which I've called offenders, and a SQL root password. I'm actually not using that, but that mechanism is in place. The pull here is from the Redhat registry, so what I will need to do is log on to that registry first. And then I'm going to run a podman exec and run effectively a SQL statement and pull in my SQL code. And this will populate the database. In my later example, we will see that using source to image, this happens automatically. I then need to create my Flask application to talk to that running pod application. And so here I've set up a simple Docker file, and we can see I've created the environmental variables that it will need to connect to the database. And then I'm going to copy my Flask code into /app, run a pip install with a file called requirements, and that will pull in all of my Python requirements. This time I'm going to expose a different port number just as a demonstration, socket 5001. And the entry point is Python, and the code Python is going to run is offenders. And the actual image is created using podman build, which you'll see here. And then I launch that image using podman run. So a quick demonstration of that. So here we see the MySQL podman image has been created. This was the code that we ran over here. It takes about 30 seconds or so for that to stabilize and for the SQL data to be inserted. So I've actually done that already, as we can see. So that pod is now running. So I now need to set up my Flask application. And in here I have a Docker file to do that. One thing to note here is that the SQL image is running on a IP address provided by podman. So we've got to patch that value over here. And so to gain that value, I actually did a podman inspect, and I'm grepping out the gateway address. So that's the address effectively that the SQL image can be located on. So at this point, I'm now ready to run my code, and we've got a very simple shell script here that will do that for me. And as you can see, it's going to actually run a podman build to build the Flask image, and that populates it to the local registry. and then I'm going to run that Flask application. Notice here I'm patching a different socket number 5001 this time. So let's go ahead and build that. Okay, so we should now have 2 podman images running, and there's the offender's entry. I've labeled it with a name of Flask there. And so that should be running on socket 5001, connecting to this SQL database. So if I fire up a Firefox entry on 5001, we get the application, this time of course running as microservices in containers, and just to verify it's actually working. So what does that give me? Well, I've containerized everything into microservices, but we've got several issues, as you can see here. Manual Docker build required when my code changes. Manual SQL image creation if I need to input or change the data input. There's no control over file pods, and I had to do that inspection effectively to get the IP address of that pod. So I'd have to do that again and recreate the Docker build. So clearly, from a commercial point of view in terms of production, this simple development model won't work. So our solution, of course, is now to move to Openshift and use source to image building. So our final task is to take our containerized applications and to migrate them into a managed infrastructure. Here I'm going to use Openshift, but we could also have used native Kubernetes. Now there are several ways to deploy our application. I've chosen a source to image approach so that the data in the SQL database will be automatically populated, and that will pull its content effectively from this URL. This is a GitHub entry from a context directory Flask with Openshift. And that will contain the SQL code to populate the database. The Flask application itself is also going to use source to image, and again it uses the same URL with the context directory set to where the code resides. Notice the use of environmental variables here. So I've got an Openshift cluster here, and we can find out a little bit about it. Do a cluster version and get nodes. So it's a 4716 cluster, fairly current, comprising 3 master nodes, 2 worker nodes, and 3 OCP storage nodes. So let's create a new project. Just call it demo. And within this directory, I've got a couple of scripts where I've just encapsulated the commands over here. So let's have a look at launch my SQL first. So we'll launch that one up. These do take a few minutes to launch. So that will begin its source to image build process. While that's in place, I'll launch this one. And of course, what we can do is we can use OC commands now, for instance, to look at the progress of the build logs, for instance. So if I do OC logs and look at our Flask build, we should see the progress it's taking. And this will take a small amount of time to execute. Whilst executing, let's go over to our Openshift console, and we'll choose our demo project. And we're going to the developer view here. And we can see from the topology view that the builds are beginning, builds are running here, and in a few moments time they should complete, and we should have our application running. We're currently looking here at the build for the Flask application. So let's have a look at the build for the SQL application. And we can see that the console just makes life a lot easier. So whilst we're waiting for those to complete, let's go back to this slide, and we'll see that this process here is, although fine, it's not easy for the end user experience. So it's much neater and easier if we can create either Helm charts or template files that we can incorporate into the Openshift console so that end users can just click to select these and run them. So a knowledge of the OC command is not required. So how I've done this, I've created templates by dumping out these commands effectively as YAML into a YAML file and then editing and taking out the superfluous information. Once you have those template files that are working, you can then run a very clever little piece of code that you'll find on GitHub called template to Helm. There's quite a steep learning process associated with Helm, but this takes the pain of that away effectively and enables you to create Helm charts. Helm charts, of course, are extremely useful because you may want to deploy this directly into a Kubernetes environment as opposed to an Openshift environment. So using the source to image model we've got here, this fixes all of the issues that we saw earlier with local containers. And as we'll see now, hopefully the build is finished. Well, it's well on its way, as you can see. Life becomes so much easier with our applications because we're building directly from source code, and we're able to do this from template files from the OC command line. Let's have a look at the template files. Actually, I'll need to add those, of course, before I need to do that, before we can see them. So I'm going to say OC apply -f. And there are two here. The first one, the ephemeral, will create our Flask application, but it won't use any disk storage. So if that disappears, if those pods get killed, then we won't be able to recreate them. The second of these two templates is the persistent one, and that will actually create a persistent volume claim. So we've added those into the demo namespace, and now if we go into the catalog entry here, I'm just going to do a search on this. Search blacklists. We can now see our Helm charts, which I've pre-populated, but we can now see we have the ephemeral and the persistent templates. And if I were to select that and click instantiate template, then this is how effectively our end user community can deploy our application without any previous knowledge of the OC command. And the template file is being pre-populated, as you can see, for ease of use, really. We're deploying this manually ourselves, so let's go back into our topology view, and hopefully at this point we're there. Excellent. So the pods are up. There's a single pod for SQL, single pod for the blacklist. And the last remaining thing I need to do now is to make this available to the outside world, to outside traffic. So I need to expose that effectively as a route. And if I get the current services that are deployed, here's the service I actually want to expose. So if I run the OC expose command, I'm exposing the blacklist entry, and I want to expose it as the blacklist.apps.ocp.local, and I have an entry in my local DNS to point to that automatically. So we notice this little tag has appeared now, and hopefully successful completion of the demonstration. This should fire up our application, and there it is. So fantastic news. So let's have a look at our cucumbers entry again, and as we can see, all appears to have worked. So the journey has taken us from developing a very simple application at the command line prompt to microservices in containers using Podman, and then moving that further along to the full source to image using templates. And that really shows the power of the developer journey, and hopefully will enable our pre-sales guys to talk to customers and do this demonstration to show how powerful the container infrastructure service is.